Hello guys, we'll be finding the Fourier transform of 1 by root mod t today. Okay, first of all, the Fourier transform formula is x of j omega is from minus infinity to infinity 1 by root mod t, which is x of t here, into e power minus j omega t dt. Okay, first, let's see it's an odd function or an even function. As you can see, let's replace t with minus t. You'll get minus infinity to infinity 1 by root mod t into e power j omega t dt. Okay. Okay. Let's see what we can do here. X of j omega is equal to minus infinity to infinity 1 by root mod t e power minus j omega t dt. Let's replace t with alpha square. I'll tell you why am I doing this thing. First, we'll make this 0. Oh wait, 1 second. Yeah. Before converting this to t equal to alpha square, what we'll do is we'll write this as x of j omega by 2. Sorry, my bad. uh, 2 into x of j omega to be, let's add e per j omega t and e per minus j omega t, which is basically real value of e per j omega t, which is 2 cos omega t by root mod t minus infinity to infinity dt. We'll just replace this with this. You'll get x of j omega to be minus infinity to infinity cos of omega t by root t dt. Okay. Now, this is basically 0 to infinity 2 cos omega t by root 1 by mod t. Root 1 by mod t is again root t because you're taking t to be greater than 0 here. Let's replace t with alpha square now. 0 to infinity 2 cos omega alpha square by alpha, and this will be 2 alpha d alpha. Alpha cancel. You'll get 0 to infinity 2 times of cos of omega alpha square d alpha. Now this is basically again e power alpha square plus e power minus omega alpha square. Where's j? Yeah, this is your j. Okay. So now again 0 to infinity e power j omega alpha square d alpha. 0 to infinity e power minus j omega alpha square d alpha. Now we know, as these two are even functions, I can always write this as minus infinity to infinity e power j omega alpha square d alpha plus minus infinity to infinity e power minus j omega alpha square d alpha. Now, root j omega alpha is equal to t. Let's say t dash. No, let's go for t itself. It doesn't matter what you start from. So this will be minus infinity to infinity e power t square. Okay. E power t square d alpha dt plus minus infinity to infinity e power minus t square dt. Okay. Now here, let's replace t with jt. Okay. I'll tell you why I'm doing this, because this all is done in imaginary plane, so you can't actually integrate minus infinity to infinity for this thing. So we'll be converting this into real by converting again to by using j here. So you basically get minus infinity to infinity e power minus t square dt plus minus infinity to infinity e power minus t square dt. Okay. So, oh yeah, I really forgot. There's 1 by root j omega here on both sides. Okay. Now let's in. This is basically Gaussian integral, which boils down to root pi. So 2 into root pi divided by root j omega. Sorry, my bad. There's also a j here again. Oh yeah, there's a plus j here and root j omega by root j omega. So you'll be getting root pi into root over j by omega plus 1 by root j omega. And is there any 2 here? No, there's no 2 here. Okay, so this is basically j plus 1 by root j omega j into 1 by root omega. And this is, let's multiply and divide by root 2 here. I'll tell you why. 1 by root 2, 1 by root omega into root 2. This becomes 1 by root 2 plus j by root 2 divided by root j. Do you guys realize this thing? This is basically e power I pi by 4. And what about this? This is e power I pi by 2 whole power 1 by 2, which is again e power I pi by 4. So both of them get cancelled. So the final answer here is root 2 pi by omega is your Fourier transform. Of 1 by root mod t. Yeah, I hope you guys enjoyed this video, and it's really informative, and it's a new way to find out Fourier transform here. I don't think so anyone has done it in this way, so I hope you guys liked it.